Hi, welcome back to the next video in the series of creating a dynamic platform. In the last video we just set up our empty project and solution, and we created a very basic core class which was our entity base from which all our other data models will inherit from. So in this video we're going to go ahead and start creating the actual models themselves to define how data will get stored in the database and how we'll consume it. So the first model we're going to want to create is the schema, or what's going to be the templates for our dynamic models. So again, this is just going to be a class, and we'll call the first one schema. And then I'm going to create another one before I actually add any code to that, called schema property. And we'll do the schema property first, and you'll see why in a minute. So again, change to public, and we're going to tell it to implement entity base. Now by default it's no idea what entity base is because we're in a completely different project, but if we go to the little light bulb here, we have this option to add reference to agility.core. So that does two things: it adds in our using statement and it adds a reference to agility.core into our project references there. So once that's done, now let's add some base properties. So this schema property is where we're going to define what a field might be. So for example, we're going to have a name, we're going to have a display text. The reason being is the internal name would generally not want to contain spaces and so on, but we might actually want to display text to a user when referencing this table that does have spaces. And then finally we're going to have a data type. Now we could, in theory, for our data type use enumerations, but for now, to keep things simple, I'm just going to set it to string so that we can dynamically change types as we need. The final thing we need to add just at the top, because this schema property is going to be a child of schema, I'm going to add in a public string schema ID, and this will allow us to link back individual schema properties to a holding schema. Okay, so once that's done, go back to our schema class. Again, tell it to inherit from entity base. This time we do still need to resolve it, but this time it's just using core.models because the reference has already been added. And in here, first of all, we want an application ID. Now we're not going to use this straight away, but the idea behind this is, because this platform is supposed to be dynamic that we're building, and we'll be able to build multiple different applications with it, we might want to group all our models under the concept of an application. So we'll have this application ID in for now. Next, so we're going to have a name again. So this is the name of our schema. Think of it as the name of a table in a database. And then we're going to have a collection of schema properties, which we will call schema properties, and this obviously will hold all our individual properties, or think of columns if you're thinking in table terms. Finally, the last thing I want to do in this one is, again, I want to create a constructor, and this constructor is just going to initialize this collection, because if we don't do that and we try to add a property, it's going to throw an error. So we're going to say this dot schema properties equals new list schema property, and that's our templating done. Next, I want to create classes that will help us store actual individual data. So if this is the template, now we need to add the implementation of any template, and I'm going to call this a data model, and again I'm going to have a data property. Again, we'll do the data property first. Again, we want to inherit from entity base. So the data property, first of all, we're going to need a link back to the parent model. We also are going to want a link back to the schema element that it's based on, so the schema property. And this will allow us to combine our actual template with the data itself, but we don't necessarily need to store all that information, so we'll have an ID as a reference. And then finally, because this is where we're going to store the actual data for any one particular data property, we need a value field to store the data. Now note, I'm always storing the data as a string at the moment. We might change that later, but the current thinking is if we could still store integers in there, but they get stored as strings, and if we did any calculations on them, we'd have to convert them to an integer first. The other option would be we could have string value, int value, bool value, and that way that is another good way of doing it, and we may switch that at a later date, but that's the great thing about doing programming in this agile type fashion. We can always go back and change as and when we need it. Finally, we've got the data model. Again, that's going to inherit from entity base. Again, so just as the data property referenced the schema property, our data model needs to reference our schema. And the only thing this is going to contain is a collection of data properties. And again, as we did with the other one, we just want to create a constructor so that every time we create an instance of the data model, it's going to create an empty list of data properties. Oops. Okay, that's better. So that's our base model setup. So as I say, so these models here, being data models, are all going to get stored in a database. So as I say, the schema will contain the template, the models will contain the actual data itself. However, as we saw in the presentation, when we actually get the data and send it to the UI, we're actually going to want an amalgamation of all this information. So we're going to want the display name, text and data type from the schema property, and we're going to want the actual value from the data property, and so on. So the way we're going to do that is we're going to create view models that will hold this combined information. So go into our view models class and create our first class, which will be model view, and another class which we'll call model view property. So again, it's a similar concept. We'll have a holding model view with a list of properties within it, and again, because one's going to contain the other, we'll do this one first. Now, because this is being stored in a database, we don't need to inherit from entity base. We might want to at a later date, but for now we'll try without it because it's only a model view. So this is going to contain the model view, like I say, a combination of what's in the schema property and the data property. So the easiest way to do this, let's go and copy those fields, and then let's get we need the value out of there. And again, we're going to need a link back to our model view. Actually, because we're not storing this in a database and it's going to be dynamic, we won't need that ID link because it's going to be a nested view. So we can just leave that as this. We've got name, display, text, data type and value. Finally, let's go to model view. Just like the schema, we want an application ID and a name and a list of properties. So let's just copy that lot and change these. So it's now model view. That's model view property, model view properties, and that's our model view. Okay, with all that built, we can then start to add these to the underlying web API. But what's usually good practice is before we go ahead and do all that work, we need to make sure that these models are going to work in the way that we want them to. So what we really need to do is write some tests to simulate adding a template, adding some data and combining them together and make sure they come out as they look. But we'll do that in the next video.